Hello students, welcome back to our class of automata. On our last class we have seen some examples over PDA, and I have also defined that same PDA can be implemented through NPDA or non-deterministic push down automata. Now in today's class we are going to discuss in detail how a non-deterministic PDA works. Now basically for a non-deterministic PDA means that we can have more than one choice. Okay, now any NFA has a nature that for same input over a particular state we can have two transition function. If we apply 0 over S, then it can go to A, and if we apply 0 over S also, then it can go to B. So if we have 0 in our input symbol, then the machine or the user will get confused where will be our next state. In the same fashion, if we have a machine like this, it is a PDA. If we get 0 and our top of the stack element is A, then we will replace this A with 1 and we will go to Q2. And in the same fashion, if we get 0 and our top of the stack is A, then we will replace it by 1 and we will go to Q3. So it is a non-deterministic in nature. On our next example, we are doing the same thing. Here only this replacement symbol is going to change. If we get 0 and top of the stack has A, then we are going to replace 0 there, and if we have 0 and top of the stack has A, then we are going to replace by 1. Now the same thing can be done like this, that here in this example we had different states, but here we have same state. We are coming from Q1 to Q2, but if we watch the input symbol and the top of the stack, then it is also non-deterministic in nature, because as you can see, if we have 0 in our input string and A is our topmost element in the stack, then we are going to replace A by 0, and on the second delta or the transition rule, we are defining that we are going to replace it by 1. So this is non-deterministic in nature. Now here what we can see is that this same type of example we solved on our last class also, when we defined that NPDA can be implemented for the language of equal number of 0 and 1s. Okay, now here as you can see that if we have 0 and then we can push 0 over the stack. Delta means this is a simple push operation. Now here we are defining that if we have 0 and A is the topmost element in the stack, then we are going to replace A by 1. So this is also non-deterministic in nature. Now here if we get nothing, that means an empty symbol from the input string, then and if the top of the stack contains B, then we are going to push 0, and here if we get 0 and this top of the stack contains B, then we are going to replace it by 1. So this is also non-deterministic in nature. So hopefully I think that the concept of non-deterministic PDA is very clear. I am again giving you one example. Now how this machine defined. Now here we are going to apply the rule that if we get 0 and top of the elements is B, then we are going to replace it by 0. Now if we get 0 and top of the element is B, then we are going to replace by 1. This is definitely a deterministic machine, because we can define the rule that if I have 0 in input symbol and top of the element is B, then do this, and if the top of the stack contains A, then do this. So this is deterministic in nature. Okay, thank you.